Picking up with example 3 from lesson 15.3, we're going to look at the integral of xy dA, where d is a region bounded by a line y equals x minus 1, and a parabola y squared equals 2x plus 6. Now, as soon as we see y squared equals 2x plus 6, I hope this reminds you of your pre-calculus days in AMA, where you could factor out a 2 and very quickly see that there is an x plus 3 in there. You might guess that the vertex would be at negative 3, 0, and indeed it is. You could see very quickly confirming by just substituting in the point negative 3, 0 that it holds true. This is also a parabola that's opening up to the right side, so it looks something like that. Now, y equals x minus 1 would have a y-intercept at negative 1, and we would have a line that would look something more or less like this. You might guess that that line is in fact going to intersect. You could confirm algebraically y squared. If you square that, you'll have x minus 1 quantity squared equals 2x plus 6. And very quickly we would get x squared minus 2x plus 1 is equal to 2x plus 6. If we get 0 on one side by subtracting, we'll have x squared minus 4x minus 5 is equal to 0. In solving, we would see that we have x minus 5 times x plus 1, and very quickly arrive at values of x of 5, x equals negative 1 for our intersections. Now, of course, the line y equals x minus negative 1 lends itself very useful. If I were to plug in x equals negative 1, you could see that your y value, negative 1 minus 1, would be negative 2. So that would be a y value of negative 2 down there. Similarly, if I plugged in y equals 5 into the line y equals x minus 1, you'd see your y value would be a 4. And what you're going to notice very quickly is this is a type 2 type of a figure. You would not want to make vertical lines. You can see that the boundaries would be changing. So what we could do very quickly instead, just finishing this topic up, is we could integrate on the inside. We know that we're going to have our x values are going to be bounded between being largest. If I solved, x would equal y plus 1. Y equals x minus 1. But if I add a 1 to both sides, I'd have x equals y plus 1. And over here, if I had y squared equals 2x plus 6, well, if I wanted to solve for x, well, real quickly we could subtract a 6 and then just divide everything by a 2 and get y squared over 2 minus 3. So we could see we'd have a left bound, a smallest bound of y squared all over 2 minus 3. Up here we'd have y plus 1. And this would be integrating, of course, first with respect to x, then with respect to y. You could see that your y values are going to span from negative 2 all the way up to 4. Now, from negative 2 to 4, that will be the very last thing that we're going to work through. But a type 1 region really would not be the way to do this problem at all. You could quickly see that we'd be in trouble. Just highlighting in green over here, you'd have a boundary of the parabola and then the line, and over here it's the parabola and the parabola. So you don't want to go that direction at all. Instead, let's just evaluate this problem. Take an antiderivative with respect to x. So treat y as the constant. We'll get x squared all over 2. Have our y right over here. We'll go from y plus 1. Down below we have y squared over 2 minus 3. And we'll certainly keep the rest of this off to the side. Let's see, using our fundamental theorem, we can say plug in y plus 1 right in here. And when we do, you'd get y plus 1 squared times y all over 2. And then we'll say minus, well now this is going to get a little messier in here, y squared over 2 minus 3 quantity squared times y all over 2. And really at this point, the only thing we have to do is just clean this up and work it out. So by the way, immediately what you could do is you could factor out a 1/2. That might be a smart thing to do. Get rid of all of the fractions altogether. Maybe that would be a nice thing. Y plus 1 squared, well we know that's going to be y squared plus 2y plus 1, and then we'll distribute a y in there. As we square this other term here, we'll have y to the 4th all over 4. Double our middle term. We'll have a middle term of negative 3 over 2y squared, but if I double that, the 2 will go away, so we'll just be left with negative 3y squared. That's not quite as bad. And then say plus 9. So things are looking up a little bit. They are getting a tad better. We could distribute that y in very quickly and get y to the 3rd plus 2y squared plus y. Distribute this negative y to the 4th over 4 plus a 3y squared minus 9. And of course, just cleaning this up a little bit, I hope you can see that our y squareds may combine into 1. So and if you want to write your leading term first, you certainly can do that. This would be negative y to the 4th over 4 plus y to the 3rd plus 5y squared plus a y, and then minus 9. What do we do next? Well, very plain and simply, we take some antiderivatives. Keep our 1/2 out in front. This will become negative y to the 5th all over 20 plus y to the 4th all over 4 plus 5y to the 3rd all over 3 plus y to the 2nd all over 2 minus 9y. And from here we're just going to have to evaluate what's happening when we have a 4 and the negative 2. So really all we're going to have to do is evaluate all of this. If you've got this nice long expression here, maybe it's a little intimidating to see that for a second. What you could do very quickly is just rewrite this up, and I know this might seem a little strange, but if you know you've got this long extended kind of a thing to work out, you can say, well, how about I type in, and this can be a little funny to see because I'm typing it in terms of x. I'm going to say negative x to the 5th all over 20 plus x to the 4th all over 4. Oops, 1 second, let's delete that. I forgot to get, there we go. I had the fraction, wanted that to show up a little lower. Here's our 5x to the 3rd, and then we'll say divide by 3, plus x squared all over 2. And then what? Well, we've got minus 9. And again, what's so funny is I'm typing this all in as an x. Well, what we're seeing is this. We had 1/2, 0.15, and then we could say parentheses vars, y vars, y1. Well, I wanted to plug in a 4, and then I'll say vars, y vars, and I'm going to subtract and then say plug in a -2. So if you work all this out, that's a nice way to do it. Looks like you'd get 39.6. Just letting the technology help you out. It's going to be a little ugly raising 4 up to the 5th and having all those fractions, but this could work it out for you pretty quickly. So that's all we've got going on for the end of that lesson. Just wanted to show you a type 2 region. Best of luck to you.